1.
As a chemistry student, now perhaps you're fully aware that most of the chemical reactions occur for substances that are dissolved in water. We call them aqueous solutions. Now, what's happening to a substance when it actually dissolves in water? Now, take note that water is a polar molecule, and because of this, water dissolves a lot of substances. In this diagram, you see the dissolution of the sodium chloride crystal to the water solvent. When the sodium chloride dissolves in water, the NaCl ionic compound dissociates into Na plus and Cl negative. This is an example of forming an aqueous solution of sodium chloride. So usually you see a subscript Aq in the chemical equation. So the moment you see the subscript Aq, it represents that the substance has been dissolved in water. And what happens is most of the ionic compounds, the strong electrolytes, completely dissociate into its component ions when they are dissolved in water. Now, for today, our overall goal is to be able to write what we call net ionic equations. So, this is not the balanced chemical equation that we usually know, but it's an ionic equation. So, it should represent the ions that participate in the chemical equation. So, when we talk about net ionic equations, there are three ways that we have there are three steps that we have to complete before we can come up with our net ionic equation. Please remember this. The first one is we must be able to have a complete molecular equation. When we talk about molecular equation, this is simply our balanced chemical equation. So always start with that. So we will be assured that the substances before the reaction and after the reaction are the same. Second is we must be able to um, we have to segregate and dissociate our ionic compounds into its ionic format. That means we have to be able to separate the cations and the anions both on the left side and the right side of the reaction arrow. And from there, just like math, we cancel out substances that have the same charges before and after the reaction so that we can get what we call the net ionic equation. So to be able to visualize what I just said, let's start with the very first example. The example of the reaction between aqueous sodium chloride and silver nitrate. This is a double displacement reaction between the two substances, NaCl aqueous and silver nitrate aqueous. Because this is double displacement, we know that sodium will pair up with NO3 nitrate and silver, your cation, will pair up with chlorine, your anion. Therefore, the products that you will get in this reaction are sodium nitrate. So always begin with the cation followed by the anion following their charges. And this is aqueous, and your silver chloride, which is solid. Now, take note of the phases of the substances. We begin with two aqueous substances, and then in the products, we still get one aqueous substance, one aqueous product, sodium nitrate, but the other one is a precipitate solid. So, solid means it is a formation of a precipitate. So we have the formation of silver chloride, which is insoluble in water. So if it's solid in its format, that means it is not dissolved in water. So this is the format for your molecular or just simply your balanced chemical equation. And then let's check whether the equation is balanced. One for each, and there's three oxygen and nitrate, which doesn't change here. One for Na, one for N, three oxygen, one Ag, one Cl. Therefore, our equation is balanced. After that, once we've already checked that the equation is balanced, we now separate the compounds into its ionic components. So NaCl came from Na plus and Cl negative, both with 1. And then you don't forget to put the Aq. So that means the Na plus and Cl negative dissolved and dissociate into its component ions when dissolved in water. Same with silver nitrate, you can split it up into Ag plus Aq and NO3 negative Aq. And then the products, which is aqueous, the sodium nitrate, you can also separate it to Na plus Aq and sodium nitrate Aq. However, for the solid, because it's insoluble in water, it doesn't dissociate, so it remains as AgCl solid. Take note, the dissociation of the ions is only for those that are aqueous in its state. So therefore, you now check what are the ions that do not change before and after the reaction. So it's obvious it's sodium. So same as in a mathematical equation, you cancel out the same elements on both sides of the equation. So Na plus and Na plus here cancels out. Your nitrate and your nitrate also doesn't change on the left side and right side of the arrow. That means you cancel it out as well. So you're left with Cl negative and Ag plus, forming your silver chloride solid, your insoluble precipitate. So therefore, when you write the net ionic equation, you write whatever is left. Always begin with the cation. So you write Ag plus Aq plus Cl negative Aq, forming your silver chloride solid. Another example. Another example is the balanced chemical. This is the balanced chemical equation of lead 2 nitrate and your sodium iodide, forming your lead 2 iodide solid. So this is your precipitate, and sodium nitrate aqueous. Balancing the equation will give you a coefficient of 2 for NaI and 2 for sodium nitrate. So this equation is already balanced. Next is we split this. We split those that are aqueous into its component ion. So lead 2 nitrate becomes lead 2 plus. Nitrate is NO3 negative. But you need to put a 2 for nitrate because this is a parenthesis here. It means there are 2 of that. So you need to transfer the subscript 2 as a coefficient because you're splitting the ions already. And then for 2NaI, you need to put 2Na plus and 2I negative. So you put 2 for both because the 2 will encompass your sodium and iodine all together. So you need to put the 2 as coefficients. And then for lead 2 iodide, because it's a solid, there's no component ions for that. But for sodium nitrate, there will be, but there's a 2 coefficient. So don't forget to write that down. So you have 2Na plus and then 2NO3 negative, both aqueous. So checking on the equation, what can you cancel out? You cancel out the ions that are the same. We call them actually spectator ions. They do not participate in the chemical equation, in the chemical reaction. So it's obvious it's 2 nitrate and then 2Na plus. So in the equation, you're now left with Pb2 plus and your 2I negative, forming your solid precipitate lead 2 iodide. Another example is your zinc. This one is already your ionic equation. Zinc solid plus copper 2 plus Aq. You have 2Cl negative forming zinc 2 plus aqueous, then 2Cl negative plus copper solid. When you're given not the balanced chemical equation but the complete ionic equation, just look out for those ions that you can cancel out. So obviously you can cancel out 2Cl negative, 2Cl negative in the left and right side of the equation. So you're left with zinc solid, copper 2 plus Aq, forming your zinc 2 plus Aq and copper solid. So it will just be easy if you're given right away the complete ionic equation. Then you can cancel out and then write your net ionic equation. Last example is for silver nitrate and sodium chloride. So it's the same thing. This is already, you're given already the complete ionic equation. So right away, you just figure out what you can cancel out. And so figuring that out, that means you can cancel out your NO3, your Na plus and Na plus. And so you're left with Ag plus Cl negative, and then forming your insoluble precipitate, your silver chloride. So take note what you cancel out are what we call the spectator ions. So this is the last example for 2Ki, lead 2 nitrate and lead 2 iodide, potassium nitrate. So don't forget that when you separate them into its component ions, you do this. not failing to put the coefficients and then cancel out the spectator ions, forming this net ionic equation. So that's it for now. I hope that you will be able to answer our exercises in the classroom and take note